So, Kale, what are some examples of mechanical energies?
Some examples of mechanical energies are kinetic energy, gravitational potential energy, and elastic potential energy.
Great, so let's do an example with Kale driving an expo marker. Alright, so let's take a look at this problem. We have Kale, who is 1.8 meters tall, and he's holding a marker which weighs 0.18 kilograms at the top of his head. So, Kale, let's look at this problem and decide what the kinetic energy is and what the potential energy is.
Well, there's no kinetic energy because there's no velocity. And the potential energy, we're going to use mgh, which is 0.18 times 9.8 times 1.8. And when you do that, it comes out to 3.1752 joules.
So for our last problem, we're going to take a look at a more complicated problem, which is a roller coaster. And for our example, we're going to use King de Ka, which is the tallest roller coaster in the world, and the track looks something like this. Alright, so we're going to try to find the kinetic energy and the potential energy for a problem like this. So the roller coaster is 139 meters tall at its highest point, which we're going to label its peak. And the second hill, when it comes down, is 39 meters tall. Which we're going to label as its second peak. So we're going to try to find the kinetic energy and potential energy at both the peak and at the second hill.
Well, once again, at the very top, the kinetic energy is 0. And for the potential energy of the first peak, we're going to use mgh, which is 409 kilograms times gravity, which is 9.8, times 139. And when we do that, it comes out to 557,139.8 joules.
Alright, so as Kale explained, we're going to use the same formula as the last time. For kinetic energy, we're going to use 1/2 mv squared. And assuming that the cart is 409 kilograms, we plug all that in, but there's no velocity, that's going to be 0. So there's no kinetic energy at the very top since the object's at rest. I'm going to put 0 for that. Now we're going to solve for potential energy, which, as Kale explained, we're going to use mgh. And the mass, which we said was 409, times the gravity, which would be 9.8, times the height of 139 meters, and we're going to get 557,139 joules.
Now we're going to solve for our kinetic energy. To do that, we need to find the velocity. And here we're going to use mgh plus 1/2 mv squared. And so you plug that in, 409 times 9.8 times 39 plus 1/2 409 times v squared. And that multiplication gives you 156,319.8 plus 1/2 409 times v squared. And then that comes out to 204.5 times v squared. And now to solve for v, we're just gonna divide by 204.5, and that's going to give us our solution of v squared equals 1,960, and then you got to take the square root because it's to the second power, and that will give you 44.22 meters per second.
Alright, so we solved for potential energy, and we solved for the velocity, so now we can solve for kinetic energy. So we're going to use the same formula we've been using, 1/2 mv squared. And as I wrote in that problem over there, we have equal to 1/2 409 times our velocity squared, which we found was 1960. And we multiply that out, we get 400,820 joules. Alright, so that is basically how you solve two basic problems for the conservation of energy. That's pretty much it. Thanks for watching.